The time machines of science fiction offer infinite possibilities. But could time travel ever be science fact?
I don't want to blow your minds here, but time travel is not even remotely science fiction. It is absolute science reality.
Time itself may be something you can bend and stretch. So in some respects, time travel may be every bit as real and every bit as strange as our wildest science fiction fantasies.
By investigating time travel, we're unraveling the deepest mysteries of the cosmos.
Thinking about time travel can teach us a lot about the nature of our universe.
It forces us to take on some of the toughest unanswered questions in all of physics.
The more we learn about how the universe works, the stranger it gets.
In Cambridge, England in 2009, world-renowned physicist Stephen Hawking threw a party. Canapes were prepared, champagne poured. But friends and family weren't on the guest list. The only people invited were time travelers.
Here's somebody who worked on the physics of black holes, worked on the physics of time, and he thought to himself, if time travelers exist, they might all come together at one specific point in space and time for a party.
The invites gave a place, date, and time. However, they were sent out after the party happened.
But he only invited people from the future who could travel back into the past.
Professor Hawking waited and waited.
Unfortunately, no one showed up.
Is this proof that time travel doesn't exist? Well, no, maybe he's just known in the future as having thrown really crappy parties.
A party without guests isn't much of a party. Could time travelers jump back in time and liven things up?
We're all moving into the future. That is, in essence, time travel. You're traveling into the future at 60 seconds per minute. It's kind of a cop-out, though. When you talk about time travel, you want to talk about leapfrogging into the future or going into the past. If we want to go to Stephen Hawking's party, which is now in the past, how do we do that?
One way would be to change our passage through time. According to Albert Einstein, that is possible.
100 years ago, Einstein started a scientific revolution which requires us to let go of our common sense ideas about what space and time are.
So instead of thinking of our universe as a three-dimensional place that just changes over time, we should think of reality as this four-dimensional place called space-time.
If you stop and think about it, all of your observations of time are directly coupled to watching something move in space, right? What is a day, really, but the rising and the setting of the sun? Or an hour, but the motion of a hand on a clock?
The three dimensions of space are linked with one dimension of time, making a four-dimensional space-time continuum. It's good news for wannabe time travelers. It means motion through space is connected to motion through time.
We move through space-time, not space or time. And the way this works is that if I'm standing still and I'm not moving through space very quickly, then I move through time as fast as is possible.
This DeLorean doesn't look like it's moving, but it is. It's moving through time. The car, its driver, and the road it's parked on are all moving through time at the same rate, second by second. When the driver hits the gas, some of that movement through time is converted into movement through space.
As soon as I have motion through space, Some of my intrinsic movement through space-time is now taken up by that motion. As I move faster through space, I move slower through time.
Scientists call this time dilation.
One of the consequences of special relativity is that clocks that are traveling faster actually run slower. And this is not just theory, it's been tested, which is incredible.
You can have two atomic clocks, which are perfectly synchronized. And if you take one and stick it in an airplane and have it move at a few hundred miles an hour relative to the other one, their clocks will now be off. And they'll be off by exactly the amount relativity predicted.
And in Einstein's world, we have to rethink even our most basic assumptions.
Before Einstein, we would go up to people on the street and say, "Excuse me, what is the time?" As if there was such a thing as the time. And then Einstein destroyed all that and said that actually each of us carries our own personal time, and they can run at very different rates.
Because time passes differently for everyone, people will have different opinions about when events happen.
Every human who's ever lived felt like that they're living in this moment that we call now. And every human feels like their now is the now.
But one wonderful thing about the universe is there's no way that could be the same for everybody. People are traveling at different rates, at different speeds. We're moving through the universe in different ways. And there's no way to define a universal now.
And the further out we look, the more noticeable this effect.
We have no trouble asking what is going on in Paris right now, right? But we do have trouble saying what is going on in the Andromeda Galaxy right now, because it's so far away that different observers will count as different things now in the Andromeda Galaxy.
And time dilation has a neat trick. It turns fast-moving humans into time travelers.
Ramping up. Liftoff.
March 27, 2015. Astronaut Scott Kelly traveled to the International Space Station. His year-long mission was to study the effects of spaceflight on the human body. Scott was the perfect candidate because he had an identical twin, Mark, back on Earth.
They did this for a variety of reasons to explore the effects of space travel and weightlessness on the human body using as controlled an experiment as possible.
Gravity wasn't the only difference between the twins. Scott was orbiting Earth at 17,000 miles per hour. So compared to his Earthbound twin, Scott moved forwards through time.
This time travel into the future isn't just an abstract physics concept. Scott, the orbiting twin, literally jumped into the future by a fraction of a second. When Scott finally returned back to Earth, because of his rapid speed, he aged just a little bit slower than his brother, and he was actually younger by a tiny fraction of a second.
17,000 miles per hour is fast, but to jump more than a fraction of a second into the future, Scott needed to go way faster.
What if Scott Kelly had wanted to let the Earth age 1,000 years while he was in orbit for 1 year? How fast would he have had to orbit the Earth to do that? And it turns out he'd have to orbit at almost the speed of light.
To put it in perspective, just how fast that is, the fastest human piloted vehicle in history was Apollo 10 that went at 25,000 miles per hour. You would need to go more than 25,000 times faster than that. That's pretty fast.